Hello and welcome to a brand new video. Today we're going to see factorial decompositions. I don't know if that's what they're called, but let's go ahead, shall we? So we're supposed to study this, at least the first of these from 7th to 9th grade, somewhere near 7th. And the first type of these, I should probably tell you what these are used for first. These are very important when you're trying to get faster results in something you can actually solve with distributive property. So there are other ways to solve these problems, but these are the fastest ways and the ones that save you more time in problems, in tests that are timed and you actually need to react faster and solve problems as quickly as possible. So we have common factor extraction. This one is based in dividing all the monomials in an expression by the same value and extracting this as a separate factor. This may sound complicated, but I'm going to give you an example. Let's say we have 2x plus 4. Yeah, it's the always 2x plus 4 you'll see out there, but it's the best I can do right now. So we have this and we want it a little more decomposed. So we do this, 2 times x plus 2. What we did here was dividing this 2 by 2, and we got an x. And we divided this 4 by 2 as well, and we got a 2. Well, actually we divided this 2x, so what we got wasn't a 2, it was an x. So we actually divided and something like x plus 4 could probably be divided into x over 2, but I've never seen anyone actually do that, so it's just my theory. Anyway, let's go on. Square difference. This is one of the easiest and I could call it my favorite even. So what we have here is an expression whose is used in this case. Well, anyway, the two numbers in this expression are squared. This could be 4, which is the square 2, it could be 9, which is square 3, and so on, even 25, 144, and bigger numbers. And they are, one is subtracted from the other. So when you decompose this one, you get an addition, a sum, and a subtraction multiplied by each other, where basically the roots of these numbers are the components of the sum and subtraction. This may seem very easy on the first sight because it's a b, it's really easy to see. But when you have to see the roots and the roots and the squares, it can be a little harder. So I told you 4 will become. Let me write you a full example. Let's be nice. We have 4 plus. No, it's 4 minus. This looks like a module, and now it looks like a square bracket. Okay, much better. We have 4 minus 9, which will return minus 5, and we want this to decompose, so we should do 2 plus 3 times 2 minus 3. This could be so many other ways, like just got down getting a minus 5, and this in the end will be the same result. This will be 6 times minus 1. I think this is another way it's supposed to be used because it doesn't really make any sense, does it? This doesn't make sense at all. So, well, this is supposed to be used when there are variables, like 4x and 9x, something like that. Well, most of the times it's using a situation like 4x minus 9, like I showed you earlier. That's the kind of place you're supposed to use it. It's normal, I think it's normal that doesn't run a situation like the one I just showed you. So anyway, let's go on. We have the perfect square trinomial. This one is slightly harder, but not so much. So we have a square number and another square number, and we have in the middle the roots of these multiplied together and then twice that result. And this symbol we have here, the minus plus, or the plus minus, oh my god, that's anything but a plus minus, Doesn't mean like there are something subtracted at the same time, which wouldn't make any sense. It actually just splits into both of these signs. So it becomes, it depends on the context. For, let's say in this context, it's supposed to mean, actually I think in this context it's not supposed to be used, but in this context it is conditional. It is supposed to mean that were this to be a plus, this one will be a plus, and were this to be a minus, this will be a minus. But in our equations and the place where it is supposed to be used is when it is meant to split into these other two options, and that's where you should use it. In an equation where this is placed because a specific equation has been utilized, like that big one for square equations, this thing actually comes to use because the equation has to split in two ways. Well, enough with the plus minus. Let's get on what the problem is. When you encounter this thing, you're supposed to just get the root of this number here and this number here, and then to check that it works, you have to get those roots, multiply them together, and multiply them by 2. And if the number matches with this one, you're on the right path. And also make sure to note this symbol here and repeat it here, so you can sum or subtract the roots together and square it. And you've done it. That's actually a factorial decomposition, and it's much easier to treat and calculate later, I think. So let's go on. We have s squared plus ps plus q. This other case can be a little, slightly harder, but not that much. It's basically a version of the one another, the one on top of it, that didn't match so perfectly. So we will have s times 2 plus s plus a plus b that multiplies s plus ab, and it will just become s plus a times s plus b. As you can see, it's much like the one on top. If you look at it carefully, it will be something like as the one that will be b changed and became two different numbers, it doesn't match anymore, and it can be 2ab. So now it has changed. It's 3 different variables, and it can, well, it's easy to get these ones messed up because they are so similar. Alright, let's go on. S times 2 or s squared, come on, s times 2 is in the right answer. This is s squared. Let me get used to it. I don't do math in English very usually. A plus b s plus ab. To use this, you're supposed to sense that this number here is something like, 18. You're supposed to see that this is a 9 plus 9, and were it to be a 9 plus 9, it will probably be the one on top. So this is a good example. Let's try something like 27. We will have that is 9 times 3, and then you can always be sure 18 was a good example. I'm really messing up right here. Oh, sorry, let's roll back for a second. 18 wouldn't be 9 times 9, that doesn't make any sense. Alright, it is supposed to mean 18 is 9 plus times 2, and that will become, excuse me for being tired. I already recorded this once, but my camera crashed and I lost all my progress, so I'm a little tired and a little stressed right now. Let's go on. 9 times 2. You are supposed to check out if 9 times 2 if 9 plus 2, 11, and oh, I remember now. Okay, let me get this straight. 9 plus 2 was supposed to show over here, so if you see that the numbers that form this product can be summed together to become this one, then you're in the right spot and you need to use this form of factorial decomposition. In order to successfully execute it, all you need to do is grab these numbers that you got from here and test it on here and put it in this way. The s, that is almost every time an s, plus a plus the first number you got times x plus the other number. And it's done. It's probably the easiest one to do. And let's go to the final one, and probably the strongest one, just like a final boss. This one, you're not supposed to solve it by this equation. Actually, you're usually not taught this equation because they don't want you to see it, they don't want you to master it this way, at least in my school. You were expected to do something like, let's say you have 7x plus 9x, this is probably not gonna work, but it's an example, plus 20. And you're supposed to get here and do 1x, or x, which makes sense, x, times 7x, and plus 7x it will be, and here we'll place, let's say, 10 and 2, and you will do this and you will get 2x and 70x, and that will sum the number that goes in the middle here, which will be 70, oh my god, 72x. That will be a right combination for this thing to work. Let me take away a few zeros here and do it as well. Let me write here 72x. That will work. And then we can easily go ahead, do this, and get the result. This will be x plus 10 times 7x plus 2. And you have effectively and successfully finished that one. As you see, you are not supposed to actually learn how to do this way because it's more comfortable, harder to master. But if you have a mind that is more driven toward numbers than toward methods, it can happen. You could also master this one. It's harder, but you can always do it. And in case you forget the method, this will always be here for you. Well, my throat hurts of talking so much, and also having to do this twice because the camera just went ahead and died. So I hope you like this video. Subscribe, like it, and please share it with your friends so I can keep on making videos and teach people some math. I'm actually doing this because I need to study math myself. I need to review these things, and these are guys I made in the past from my school, and I wanted to share them with the world so they can be of use to more people than just me, since I probably won't be using them so much after this day. So thanks for watching, and see you in another video.